Hello, precalc. I hope you enjoyed 5-2. I like those little problems. They're fun and you can do them so many different ways. All right, this one here's 5-3. There's three different things in here. There's double angle, half angle, and power reducing. Now, again, you should have all of these on your thing, so it won't be too hard. You just have to know how to use them. And make sure you know your formulas. And don't get too scared by them. They just look worse than they really are. All right, we're going to start with a double angle. So this is like sine of 2 theta, tan of 2 theta, cosine of 2 theta. If you notice, sine and tan, you don't have options. Cosine, you have many. Sine squared minus cosine squared minus sine squared is 1. 2 cosine squared theta minus 1. And then 1 minus 2 sine squared theta. We use the one that helps us the most. And it's usually dependent on where we're going. So this one here has a little bit more thinking involved. First of all, let's show you how it works with a straight angle. Okay, I have to get to 120. So 2 times what equals 120, and that's 60. So 2 times 60 is what we're looking at. So 2 times 60, so this has to equal my 120 in here. So now this is the double angle of cosine. So we're using the formula above with 2 cosine. And it doesn't matter which one we use in this because I'm not trying to do any proof. I just chose the first one. So we go cosine squared theta minus sine squared theta are 60. I know that the cosine of 60 is 1/2. I just square it. I know the sine of 60 is square root of 3 over 2, and you square it. It's just 1/4 minus 3/4, and we get negative 2/4 or negative 1/2. Nothing too earth-shattering here. All right, pause and try yours. So again, yours would have been sine of 2 times 60. All right, but now you got to use the sine rule, which is the 2 times the sine of 60 times the cosine of 60. You don't get any options on the sine. So now we know that this is 2. We know the sine of 60 is the square root of 3 over 2. And we know the cosine of 60 is 1/2. Now we're just multiplying these through. Oh, this is 2 over 1. So we know one of these 2's is going to cancel, which is going to equal the square root of 3 over 2. And we are finished. I hope you did well. All right, next, we also need to look. Sine of 120. So we know this is sine. This is in the second quadrant. So second quadrant sine is positive. So this is a positive value. All right, whoops. I'm not sure what I did there. Hold on. All right, now we're going to use right triangles to solve also to show you another method. It's just something that I personally think makes sense because you can see it. All right, I want to find the exact value of 2 theta if I know the sine of theta is 4/5. All right, so 4/5, and I have to tell you where it lies. It lays in quadrant 2. So I'm going to draw, here's quadrant 2. I'm going to draw my line up and down. 4/5, so I know this is opposite over hypotenuse. So I'm going to lay on my 4 and my 5. I don't know what x is. Well, that's pretty easy to find, right? X squared, a squared plus b squared equals c squared, your Pythagorean theorem. We're going to plug this in. We're going to do the square root, and we get 3. But I know I'm on this side, so I know this is negative. So this guy is negative 3. Good to this point. Now I know the cosine of 2 theta is 2 times the sine of theta cosine of theta. Well, this is my theta right here because it's my reference angle. I know the sine is 4/5. I can plug that in. I know the cosine is negative 3/5, and I can plug this in. Now all I do is multiply. 2 over 1, so 2 times 4 times negative 3, negative 24 over 25. And that is the exact value of the sine of 2 theta when theta is 4/5, or the sine of theta equals 4/5. Okay, pause and try yours. Again, sine of theta was 4/5, and we were in quadrant 2. So we have the exact same triangle this time. Draw this up, draw this down. Sine is 4/5. A squared plus b squared equals c squared gives us the negative 3 here. This is our theta that we're looking at. Cosine of 2 theta. Again, this is one you kind of get to choose. So since we don't really care, I'm just going to do the sine squared or the cosine squared of theta minus the sine squared of theta. You could use any of them and come up with the exact same answer. So the cosine squared of theta, okay, I don't know why that disappeared, is a negative 3/5 squared minus the sine squared of theta, which is 4/5 squared. Square these, we get 9 over 25 minus 16 over 25, which gives us negative 7 over 25. Any way you've done it, you should have come up with the exact same answer. All right, these are the ones that get fun. Okay, now we have to verify that the sine of 3 theta is equal to 3 sine of theta minus 4 sine cubed. Okay, so remember, we try to start with one and work to the other. Well, 3 theta, we're going to use angle addition. I know that's 2 theta plus theta. All right, now let's use our sum identity. So that's a sine 2 theta cosine theta plus cosine 2 theta sine theta. We just did the angle addition from last section. Okay, double angle. The sine of 2 theta, we have no options, is 2 sine theta cosine theta from here, plus now the cosine theta, I have options. But I know I need to be an all sine. So since I need to be an all sine, I'm going to use the cosine that only has sine in it. So we're going to choose the 1 minus 2 sine squared theta, sine theta. Okay, let's see how this helps us. So I'm going to multiply this out. We get cosine squared theta. I'm going to distribute the sine through. So that's sine minus 2 sine cubed theta. Okay, that's not bad, but I still have to be in all sines, but I have this cosine squared. Well, cosine squared, I know, is equal to 1 minus sine squared from our Pythagorean identity. So we're going to plug him in. Let's distribute, see what this does for us. 2 sine theta minus 2 sine cubed theta. Can't do anything over here yet. Let's see what we got here. Let's combine like terms. So I got a minus 2 sine cubed theta, a minus 2 sine cubed theta, which is minus a 4 sine cubed theta. 2 sine theta plus sine theta is 3 sine theta, which is exactly where I wanted to be. So by choosing wisely, it led us to a very nice proof. Okay, pause and try yours. Be careful. All right, so again, you would have started the same way. Cosine of 2 theta plus theta. My theta is not showing up very well. All right, so now you got to use your double angles or your angle addition. And we know that angle addition of 2 cosine theta, or 2 theta plus theta, is equal to the cosine of 2 theta times the cosine of theta minus the sine of 2 theta times the sine of theta. All right. We got now, I know the cosine of 2 theta. We've got to get to all cosine here. So this is what we're working on. 2 theta. So I know that 2 theta, and I'm going to use the one that uses only cosine. So that's 2 cosine squared theta minus 1 times the cosine of theta. All right, what can we do over here? I've got, okay, 2 theta doesn't give me any options, so we're just going to put in what we got. So we have 2 sine of theta cosine theta is what that equals, times the sine of theta. All right. Not helpful yet, right? Let's see where this is leading. Let's distribute this. So this is 2 cosine cubed theta minus cosine theta minus, well, I know that sine times sine, we can do that. So that's 2 sine squared of theta. Oh, look at there, isn't that pretty? Because we know that the sine squared of theta, okay, let's write this down again. 2 cosine cubed theta minus cosine theta minus 2, while the sine squared is 1 minus the cosine squared of theta. At least we're finally to all cosines, right? Cosine theta. Okay, I'm running out of room here. So I'm going to cheat just a little. I do 2 steps in one. Cosine cubed theta minus the cosine of theta. Now here, I'm really multiplying -2 and cosine through to here. So -2 times 1 and the cosine times 1 is going to give me -2 cosine theta. Same with the other one. So -2 times this is a positive. So 2 cosine cubed or squared times cosine is 2 cosine cubed of theta. All right, let's combine some like terms here. So 2 and 2 gives me 4 cosine cubed of theta minus this here equals 3 cosine of theta. How close are we? Oh, look at there. Life is beautiful. So just a little bit of work, paying attention to where you want to go, and those are kind of fun. Power reducing. All right, I will tell you these are not used very often. At least I don't use them very often. So I'm going to do a short example of one of these and not be too awfully worried, but you still have to know them. And again, those are formulas that you have. So sine of 4x, okay, the best I can do is sine squared squared. Okay, let's use our power reducing here. So sine squared is 1 minus cosine 2 theta 2. So I put that in there squared. So now I'm literally going to square this. So you're taking 1 minus cosine 2 theta x times 1 minus cosine 2x, which you know is 1, double the middle, so you get minus 2 cosine 2x, square the last, cosine squared 2x, all over 2 squared, which is 4. Okay, let's divide this up so we can work with this a little better. So this is 1/4. This guy is 2 divided by 4 is 1/2. Then 1 divided by 4 is just 1/4. All right, I still have this cosine squared of 2x. So I'm going to use this one now, right here. So I'm going to do 1 plus cosine of 2 times the angle. Well, this time my angle's doubled, so it's 2 times 2x. All right, over 2, which is multiply the 4 by 2 and you get 8. This in here, for some reason, I doubled it. Did I do this 3 times? What was I thinking? All right, now we're going to reduce this out. So 1 divided by 8 is 1/8. This becomes 2 times 2x, which is 4x over 8. And now I can combine these numbers since they're straight numbers. 1/4 plus 1/8 is 3/8. These two stayed alone because they are different, a 2x and a 4x. Kind of weird, huh? But not too bad. All right, last but not least are half angle identities. Again, you get these on your thing, you just got to know how to use them. So I want to find the sine of 15. So that means something divided by 2 has to equal 15. Well, 2 times 15 is 30. So I'm going to put 30 in here because this equals 15. So this is the angle I'm using is 30. We're using the one on the top, the sine. So go 1 minus the cosine of 30 over 2. We know the cosine of 30 is the square root of 3 over 2. So now we're going to take, let's move this over. We're going to get a common denominator here and put him over 2. So now I get 2 minus the square root of 3 over 2. Multiply by your reciprocal or get a common denominator, whatever one you like. So that's 4, come on, right, over 2. 2's cancel. We get 2 minus the square root of 3 over 4. All right, if the denominator is a perfect square, I expect you to take that. If it's not, you can leave it there. But since 4 is square root of 4 is 2, you should reduce that to 2. And that's done. We're happy. Okay, pause and try yours. I should have given you more room here. I apologize. All right, so now you should have said, hey, that's the cosine of 300 divided by 2, because 300 divided by 2 equals the 150. So now we're using our cosine, which is the square root of 1 plus the cosine of 300 over 2. I know the cosine of 300 is 1 plus 1/2 over 2. Let's get some common denominators here. So this is 2 over 2, and this would become 4 over 2, and we are left with 2 plus 1, which is equal to the square root of 3 over 4, which is the square root of 3 over 2. Okay, be careful though. Cosine of 150, this is cosine in the second quadrant, which means this dude must be negative. So be careful. Your quadrant is 2. So cosine is negative. Don't forget to check. All right, I think that's it. Good luck on your homework. Make sure you post questions if you have any. I almost forgot to explain this. This review day down here, so this is what you're supposed to be working on today. And then the next time we have a review day, which is just going over what we've learned to make sure we got those. All right, so these are 2 separate homework assignments. This is the one you're working on now. This is one you'll be working on later. All right.